Hi everyone, we are back for Exponent Rules Part 2. So if you haven't watched Exponent Rules Part 1, I would go back and take a look at that. We go through 3 exponent rules, and in this video our plan is to add on 2 more. Okay, so when we're dealing with exponents, sometimes we end up with expressions that look something like this. I might have a 3 times a 5, and these things are squared. So what I have is some sort of operation in here. In this case, it's multiplication, and I'm squaring it. So we've seen in past videos that if I were to be adding on the inside and I squared, I would have to do something like FOIL. But in the case where we're multiplying on the inside and then or dividing on the inside, exponent rules actually are going to help us out. So to give this some context, let's work through this 3 times 5 squared. What does everything mean? And then we'll see what happens. So one thing that you could do is take 3 times 5 and make it 15 and then square that. I'm not going to do that because I think it obscures what we're going for here. So what I'm going to do is I'm going to leave the 3 as a 3, I'm going to leave the 5 as a 5, and I just want to see what happens when I square it. Okay, so a 3 times 5 squared, so that would mean I have a 3 times 5 here. Okay, so 3 times 5, and since I'm squaring it, I would multiply it by itself 2 times, so this would be another 3 times 5. Okay, so I got a 3 times 5 times another 3 times 5. Well, since we're multiplying everything together, since these are real numbers, we can switch the order of all of our multiplications. And I can rewrite this as 3 times 3 times 5 times 5. So I'm just going to put everything together. I'll put the 3's together, and I'll put the 5's together, because I like things organized. And it turns out, well, a 3 times 3, there's 2 3's there, so that's 3 squared. And I'm multiplying this by 5 times 5, there's 2 5's there, so that's 5 squared. So to me it looked like what happened was this exponent 2 here, the 2 went on with the 5 and it went to the 3. So I got 3 squared times 5 squared. So let's do another expression like this. I'll do it in a different color. Let's do it in blue. Let's say we had something like 4x and I wanted to cube it. Okay, so now I don't have numbers. I have a 4 and I have an x, which I can't combine. So it's going to be important for me to think about what's going on. Well, 4x cubed means I want to take this 4x and multiply it 3 times. I'm going to get a 4x, and I'm going to get a 4x, and I'm going to get a 4x like this. Well, very similar to what we did before, I'm just going to regroup everything. So in my previous example up here, I put all my 3's together and all my 5's together. So what I'll do here is I'll put all the 4's together, and I'll put all the x's together. Right, so I'm going to get 4 times 4 times 4 times x times x times x. Okay. So 4 times 4 times 4, another way to write that is 4 cubed. X times x times x, another way to write that is x cubed. So again, it looks to me like if I'm multiplying the inside of my parentheses to some exponent, that exponent is going to go to both of these terms. So it happened up here, and it happened again down here. And so hopefully these examples give us some insight into why this upcoming rule is going to work. So the rule goes something like this. If I have some multiplication that's raised to an exponent n, a times b to the n, much like we did here, this n is going to come down and it's going to appear on the a, and it's also going to go on the b. So this is our fourth exponent rule here. If I have a multiplication a times b to the n, that's a to the n times b to the n. So hopefully these give us some understanding why that's true. Okay. So I'm going to pause, clean it up, and we'll come back and we'll look at another exponent rule. All right, so I've cleaned this up, and we have our exponent rule up here in the top right that we just discovered. If I have a product inside parentheses, a times b to the n, that becomes a to the n times b to the n. So the next natural question is, well, what if I have the same set of parentheses, but instead of multiplying, what if I'm dividing? Well, let's take our same example as before, 5 and 3. We're going to divide them, and I'm going to raise it to the second power. So I'm going to square this. So just like we did before, what we have is we have this fraction 5 over 3. I'm squaring it, so that's going to be 5 divided by 3 times 5 divided by 3. So I'm taking whatever's inside the parentheses and I'm multiplying it by itself. That's squaring it. All right, so we have fractions here, and we're multiplying them. So what I can do is multiply the numerators and multiply the denominators. So this is 5 times 5 divided by 3 times 3. Okay, and another way to write that is, well, this is 5 times 5 is 5 squared, and 3 times 3 is 3 squared. So we see a very similar behavior. We had this exponent in our multiplication problem where the exponent went to both the pieces, and we have something very similar here. When I have 5 divided by 3 and I'm squaring it, the end result is the 2 ends up as an exponent on the 5, and it ends up as an exponent on the 3. So let's go ahead and do one more example. We'll do it in blue again. And so let's do 4 divided by x cubed. Okay, so we'll do a similar example again. All right, so in this case, I don't have a number, I have a variable. So I can't just combine these. I need to leave it as a fraction. So 4 over x cubed means I'm going to multiply this through 3 times. 4 over x times 4 over x times 4 over x. And these are fractions, so I'm multiplying them all together. I have 1, 2, 3 4s in my numerator. So we'll go ahead, and this becomes 4 cubed as a numerator. And I have 3 x's in the denominator, x times x, which is x cubed. So again, we see this property where if I have a division inside my parentheses, the exponent that's going there, it shows up on the 4, right? So it's 4 cubed, and it shows up on the x, it's x cubed. Okay, so to write this out in general, what we have is, if I'm dividing some numbers like this, a divided by b, so we'll use similar notation to our previous rule. A divided by b to the n is going to be a to the n power divided by b to the n power. All right, and so this is our fifth exponent rule. Okay, so in the next video, what we're going to talk about is some of the negative and fractional powers. So what I think about is, for the first 2 videos we've seen here, those 5 exponent rules are our natural ones, our basic exponent rules. And so be sure to tune in for part 3, where we start talking about what happens when you get a negative exponent, what happens when you get a fractional exponent, or what happens when you have 0 as an exponent. So I'll see you then.